So welcome back students. Before going to study about the assignment problem, first of all we will find the difference between the assignment problem and the transportation problem so that assignment problem will become more clear for us. Fine. So let me write the heading here. Difference between TP and AP. So what is TP here? TP is transportation problem, and what is AP here? It is assignment problem. So it is like TP at this side and here AP at this side. Fine. So let me divide the board here into two halves. So underlining these two here, TP and AP. So what is the first difference here? Fine. The first difference is number of sources. Number of sources and number of destinations. Need not to be equal. Need not to be equal. So remember our transportation problems where there are D1, D2, D3, D4 destinations, but origin O1, O1, O2, O3. It means that the number of destinations should not be or not compulsorily to be equal. Means what? Number of source should not be or may not be equal to the destination in the case of transportation problem. Fine. So in continuation of this, the cost matrix is not. It means what? The cost matrix not necessarily a square matrix. It means what? If the number of destinations is not equal to the number of origin, it is not necessarily to be a square matrix in case of transportation problem. Whereas here, since assignment is done on one-to-one basis, the number of sources and number of destinations are equal. Hence, the cost matrix should be a square matrix. Means what happens in AP? Because the assignment is done on one-to-one basis, that's why that is nothing but number of source should be equal to number of destinations, and it should be a perfect square matrix. So when we learned about mathematical formulation of assignment problem, there I have told you that is what the cost matrix should be of should be n cross n matrix. That is, number of rows should be equal to number of destination. The same thing it is matching here. The number of source should be equal to the number of destinations. Hence, the cost matrix should be square matrix because the assignment is done on one-to-one basis. Whereas in case of Tp did not be a square matrix. Fine. So the second one here, Xij, the quantity to be transported from ith origin to the what? Jth destination. Can take any positive values and satisfy rim requirements. Whereas in case of assignment problem, so let me again finish here. Xij is the quantity to be transported from ith origin to the jth destination, so it can take any positive values and satisfy the rim requirements. Here it is Xij, the jth job is to be assigned to the ith person and can take either value 1 or 0. So what happens here? Jth job is assigned to the ith person. Fine, on one-to-one basis, perfect square matrix, and can take either 1 or 0 values. Fine. So here the third difference is the capacity and rim requirements One minute. The capacity and the rim requirements value is equal to AI and BJ for the ith source and jth destinations. So what here? The capacity and the rim requirements value is equal to the AI and BJ for the ith source means what? A summation of AI is equal to summation BJ should be equal. Means what? The transportation problem has to be balanced if you want to solve it. I mean to say the number of sources should be equal to the number of destinations. Fine. The summation, I mean to say summation of AI is equal to summation of BJ. Means the rim requirement will be satisfied and the transportation problem is balanced. Hence there exists initial basic feasible solution. Fine. So the third one here, the capacity and rim requirements value is exactly 1. That is, for each source each destination the for each destination means what? There is exactly 1, that is for each source each destination is assigned. Fine. So 1-to-1 basis. And the last fourth one is the problem is unbalanced if the total supply and total demand are not equal. Fine. So here it is fourth. The problem is unbalanced if cost matrix is not a square matrix. Fine. So these are the differences. So let me repeat these once again here. So the first one is for the TP, number of the sources and the number of destinations need not to be equal. Fine. So it is not necessarily a square matrix. Whereas here the assignment is done on 1-to-1 basis in assignment problem. So the number of sources should be equal to the number of destinations because the cost matrix is a what? Square matrix. Whereas for the transportation problem, Xij is the quantity to be transported from ith origin to the jth destination. So it can take any positive value and satisfy the rim requirements. Whereas for the assignment problem, Xij, the jth job is assigned to the ith person on 1-to-1 basis. So it can take either 1 or 0 value. Find the third, the capacity and the rim requirements values equal to the summation of Ai should be equal to the summation of Bj. That is ith source and jth destination. Whereas for the assignment problem, the capacity and the rim requirement value is exactly 1 because the assignment is done on 1-to-1 basis. So for each source there is a destination. Specified destination is assigned. Fine. Then the last one is the problem. You can say it is unbalanced if it is like summation Ai is not equal to summation Bj. Fine. So total supply should be equal to the total demand. If the total supply is not equal to the total demand, we can say the transportation problem is unbalanced. Whereas in case of assignment problem, if I say the assignment problem is unbalanced if the cost matrix is not a square matrix. It has to be n cross n. Fine. Thank you, students. Fine. These are the differences of what transportation problem and assignment problem. The 4 differences. So this difference is asked in university examinations for 4 to 6 marks, either in the main question or in the short notes. Fine. So make sure that you practice these 4 differences. Fine, because it is one of the most compulsory question asked in examination. Thank you, students.